John Blichmann joins me this week to discuss heat sources for beer brewing. This is BeerSmith Podcast number 183. This is BeerSmith Podcast number 183, and it's early December 2018. This week, John Blichmann joins me to discuss gas and electric heating options for your brewery. Thank you to this week's sponsors, Craft Beer and Brewing Magazine. They have a new Craft Beer and Brewing Magazine podcast, which I encourage you to check out. It features some of the top craft brewery owners and brewmasters discussing brewing techniques and flavors in beer. It's the podcast for those who make and drink great beer. You can find it on iTunes or at beerandbrewing.com/podcasts. And also the Riptide Pump from Blichmann Engineering. Designed for home brewers, this pump features a whisper quiet sealed housing, a removable tri-clamp stainless steel head that's easy to clean, and a built-in relief valve for easy priming. It also has the integral Blichmann linear valve for precise flow control. Get the Riptide Pump today, another great innovation from BlichmannEngineering.com. Again, that's BlichmannEngineering.com. And finally, BeerSmith 3 is available now for download, and also the mobile version is out. BeerSmith 3 adds mead, wine, and cider recipe support to the BeerSmith platform, along with new integrated water profile and mash pH tools. Dozens of new features, including cloud folders, updated databases, support for fruit, juice, and honey, as well as new Whirlpool hop options for beer. Download your free 21-day trial of BeerSmith software today from BeerSmith.com. And now let's jump into this week's episode. Today on the show, I welcome back John Blichmann. John is CEO of Blichmann Engineering, a premier producer of home and professional brewing equipment, as well as a brewing instructor and longtime home brewer. John, it's fantastic to have you back on the show.
Great to be here, Brad, always.
So what have you been up to lately? How are things up in Indiana?
Well, it's getting to be a little bit like winter these days. Had a nice warm fall, but getting a little chilly out, and it's just kind of time for brewing, especially for the holidays.
And how are things at Blichmann Engineering?
Doing well. Can't complain at all. Living the dream.
Yeah.
Making beer equipment and getting paid for it. You can't beat that.
There's worse jobs probably, right?
I've had some of those, including dishwasher.
So have I. I've had some, although I wasn't a dishwasher, but I've had some bad jobs. Well, today you wanted to talk about heating sources, which are obviously critical for both mashing and boiling. What are some of the things you look for in a heating source?
Well, one of the main criteria to start with is, what you have for energy sources. So really it's some kind of fuel, propane or natural gas, or the other option would be electric. I'm not aware of anybody that's done a solar-powered heating source, but those are the predominant ones. And the key thing with the heating source is making sure that you have enough power to get the job done properly and in a reasonable amount of time. Right.
So the bigger batch you're brewing, obviously you need more power, right?
That's right. So you just want to have enough, to heat it in a safe manner. And, for example, a smaller batch, 2 to 3 gallons, you can generally do that on a residential stove. But you get into bigger batches, as you're talking about, and, that the game changes there. Those stoves just don't have enough power to get the job done. So.
Yeah, I remember doing, even 5-gallon extract batches were kind of marginal on the, like an electric stovetop.
Yeah, it takes forever, and you get a simmer, and that's about it.
Yeah.
And one of the other things too is whether you're going to be or can brew outdoors, or if you have to do it indoors or want to do it indoors. So those are some other considerations.
Well, obviously the main choices you mentioned are gas and electric. Let's start with gas heating, which is probably the most common for home brewers, right?
Yeah, it is. It's very inexpensive to get started. I mean, I've seen burners for less than $50.
Actually, now's a good time to pick them up because they have turkey burners on sale usually right after Thanksgiving, right?
That's right. You can get those pretty cheap all year round, actually.
Yeah. Home Depot or something like that.
Hmm.
So what are some of the things we look for in a gas burner?
Well, one of the main things to look at is the heat output, and the main unit we use here in the States is BTU per hour. And a BTU is a British thermal unit. It basically is the energy required to heat 1 pound of water 1 degree Fahrenheit. So it's a real odd unit.
And of course, for our metric listeners, that would be.
The real unit users, that would be kilowatts, which is a much easier unit to manipulate. But so you'll see in the States they're listed by BTUs per hour.
And some of them have some pretty spectacularly high numbers, right?
Right. Yeah. Some are, they can put out tremendous amounts of power. That's for sure. Some manufacturers don't list their ratings. Others list them and they're accurate, and others list them and they are, we've measured them. It's a fairly simple thing. I can talk about that in a bit. To actually measure them is fairly easy, but a lot of manufacturers they just have very inaccurate readings. And it's important to know too that rating is not how much energy goes into your actual wort or hot liquor. That's the amount of fuel that you're burning. So, expect, in that 30 to maybe 40% of that energy is actually going into your wort or your hot liquor.
Right, because most of it's going up just as heat straight into the atmosphere, into the equipment around it, right?
That's right. That's right. That's why it can get pretty toasty on brew day when you're by one or two burners that's going full tilt.
And how do you go about measuring it? While we're on the topic, I guess.
Sure. This is something that we've done, as we're developing burners, and we've tested lots of burners over the year. The main thing is to get a scale that can accurately measure that, up to about 40 or 50 pounds to within 1/10 of a pound. So you're going to be measuring the amount of fuel that you burn in 1 hour, and it's quite simple. You take the regulator off of the burner so that the weight of the hose doesn't influence the measurement. You put the propane tank on the scale and measure it. Write that number down. And then you connect the regulator up and you burn it at full tilt. What I like to do is have a kettle full of water on top of it, because the kettle does influence the quality of the burn. So there's just raw fuel burning. You can do that without a kettle on it just to see what it puts out. Problem is it may not really burn that efficiently or effectively when you have a kettle on it. So it kind of depends on how you want to measure that. If we're looking for just raw power, we just burn it without a kettle on it. So you'll run that for exactly 1 hour and turn it off with the regulator or valve all the way open. And then you just weigh that scale. You put that on the scale and weigh it again without the hose on it. And then you multiply the difference there. So say it's, 1.5 pounds that you've burned over an hour. You multiply that by 21,700 BTUs per pound. That's the energy that's in 1 pound of propane.
And you can, I assume you can look that up in metric as well if you want, right?
Oh yeah. You can look that up in metric too. You can Google the higher heating value of the fuel. That's the typical unit number that's used. You also see lower heating value, which is probably more appropriate, but I think most manufacturers like to make their number as big as possible, so they just use the higher heating value. Difference is the steam or the water vapor is not condensed in one and it is in the other. It's not that big of a difference. So again, remember that only 30 to 40% of that's going into your kettle too. So that's how you do it. And, I've seen some manufacturers that are just spot on. We try to be as accurate as we can with our products. And I've seen some manufacturers that advertise 200,000 BTU per hour that really are about 50 or 60,000. So, I think a lot of it is just not knowing. I don't think anybody's really trying to deceive anybody. It's more just not really knowing how to measure it and not taking the time to do it.
Wow, that's interesting. So,
Yeah.
what I was going to ask. So you got the BTU output. What do you need to do a 5-gallon 19-liter batch, and what do you need to do maybe a 10-gallon or 38-liter batch roughly for ratings?
5-gallon, you can get it. If you've got 45,000 BTU per hour, you can get a pretty decent heating rate and get a decent rolling boil. That's the other thing is you don't want to simmer. You want a decent rolling boil. You don't need to do 20% evaporation either. That's a little extreme. But, having something in that 10% evaporation per hour is fairly typical for home brewing. If you're doing a 10-gallon batch size, you'll probably want something in the 60 or 70,000 BTU range. And larger than that, you're probably talking, 80 to 100,000 BTU per hour to get, say a 15 or 20-gallon batch done in a reasonable amount of time.
Do you know how many watts that is roughly? If you're working in metric, or
I would have to
calculate. Okay, well, you can convert it. I mean, it's certainly possible. I get the metric people always sounding me because I haven't got everything in metric. Well, we skipped over, but what's the difference between, you say, using propane versus natural gas, and what are the advantages of each?
Oh, great question. Well, the advantage of natural gas is per unit of energy, it's generally less expensive. It's piped to your house, so you don't have to go hustling tanks of propane around and worrying about running out and all that. So, really, it's a great fuel. The only issue is it's delivered at a much lower pressure to your home for safety reasons than what's in your propane tank. You can see regulators for propane tanks up to 20 or 25 psi, where coming to your house is typically about half of a psi that's coming in. So it's really the ability to deliver enough fuel to the burner, that you can reach the level. So I typically see, if you're running something on natural gas, it's about half the output of propane, in that neighborhood. So it still can be done, and it's definitely convenient, but you will have less power output just because of the advantage of one, propane just has more energy. It's just a bigger molecule. It's got more energy per given weight. But it also comes in at a lot higher pressure, so you can just ram a lot more fuel through your burner.
Right. And the propane tanks, of course, I can't remember. The propane tank's what, like a 15, 17-pound tank? The regular tank, standard tank that you use for grilling hot dogs. How many uses can you get out of that for how many batches you can get out of that typically?
It somewhat depends on your batch size, too, and how big your burner is, obviously. But typical is 2 to 3 batches out of a tank. You can get more, if you're doing, 5-gallon batches versus 10, of course, but it's in that neighborhood. Okay.
Well, I wanted to talk about the anatomy of a burner, and you kind of broke out for me in some of the notes you sent me, all the different parts of the burner and most importantly, how to adjust them to get the proper burn.
Right. So there's a couple of different types of burners. There's the cup burners. It just looks like basically almost like a ladle, where it's got the cup, and its intent is really just to be an extremely low cost burner that puts out a decent bit of heat. And then the other type is a nozzle type where it's got multiple small holes, usually somewhat similar to what you'd have on a residential stove. So the main parts are pretty much all the same. You've got your injector, otherwise known as orifice, and that meters the amount of fuel that goes in to your burner. You can't just connect it directly up to a propane tank and pump in as much as you want. It just you have to have enough air to burn that, and it also wouldn't be safe. So the orifice, it's basically a small brass fitting with a very small hole in it, something a 1/16 of an inch or less, not very big, and that not only does that, but it actually shoots a stream of gas. And that shoots it into your venturi. And a venturi is a shape like if you think of a cooling tower that you'll see at power plants that have that kind of hourglass shape. That shape actually induces a draft when things are going through it, when from the the cooling air going through it, and that helps draw the fuel in and also blend it. So they have that shape for a reason, and that's to help the air draw in through it.
Right, and the goal there is I assume is to get the right fuel air mixture, right? Because it's only going to burn at a certain fuel air mixture, right?
That's right. Yeah. You can too lean, and it's either not going to burn or it's going to burn erratically. Too rich, and it'll burn yellow, and that's just not very hot, and it also blackens the bottom of your pot. So there's a range that the burner likes to operate, which then brings on the damper. The damper is the little metal plate on the back with a hole or holes in it that you can turn to adjust the amount of air that comes in through the venturi, and then it exits through a series of nozzles. They're just little bumps on the outlet of the burner with a hole in it, and that's where the fuel and air. At that point, there's not enough air to support combustion. It won't burn. That way, it doesn't burn inside of the venturi. But then it ejects out through there, and that's where it mixes with the final amount of air and can burn. Then of course you've got the supporting pieces of the burner, the frame. Which will, a lot of them are including a ring that helps, with wind. You'll have legs for support. One of the things to factor in is, the height is important. Some burners are really low to the ground, which means if you want a gravity drain into your fermenter when you're done, you're going to have to lift the kettle to drop it down. And, a small batch, that's not a big deal, but lifting a 10-gallon batch is kind of a pain. So having one that's, gets your height up is helpful. So you can just drain there. The other thing is, we talked about how much energy goes into the kettle, and the rest of that energy is just going to the atmosphere. But it's also going to get onto your valve and your thermometer. And thermometers in particular don't appreciate that kind of heat, and you can permanently damage the hermetic seal in your thermometer. If you've noticed, if they're fogging up inside, that generally means that you've damaged the seal, and then water vapor can condense inside the thermometer. Eventually, your thermometer can fail.
So you're talking about a thermometer maybe mounted on the side of the boil tank or something like that?
Yeah. Mm-hmm. If you've got one mounted on the side there, so having some kind of heat shield to deflect that heat off away from the valve and the thermometer is very helpful.
Yep. So, and you probably don't want it on your controller or your thermocouples and other stuff like that either. It's going to throw everything off, right?
Right. Absolutely. You do have to be careful, with the heat. We can talk about, some safety stuff later along those lines. So,
next is how do you adjust the burner to get the best performance out of it?
Okay, so adjusting is a pretty simple matter. It's really a visual and audible condition that you're trying to set. So what you really want for maximum efficiency of the fuel burning is a pale blue flame that's very quiet. If you're hearing a grumbling, or the flames are lifting off the nozzles, or they're a bright blue, you really don't have the optimum from an efficiency standpoint mixture of fuel and air. So what you'll want to do is turn your fuel up, and if you start hearing the flames lifting, turn it back a little bit, and then adjust your air damper. For most dampers, start with it about halfway open, and then you can add more air if the flame is yellow, or if it's just you basically want to turn that up until you start hearing the flame, and then back it down a little bit, and that'll get you the proper amount of air. And you can increase and decrease the fuel, but expect to be to need to adjust that damper. Lower power burners, you don't need to do as much adjusting. Higher power burners, you're going to need to do some adjusting, because you're really pushing the limits of what that burner can do. So
and I think you want to adjust it at the operating setting, right? Because obviously, the burner itself is adjustable, right?
Right.
So you're playing with the gas flow.
Yeah. The other thing that's important is to make sure that your kettle is on it, because the kettle influences how the air gets to the nozzles and the in the burner in general, and that will help you actually tune it. So if you try to tune it and then put the kettle on it, it's going to be different. So have your kettle on it, set your valve, the fuel flow where about the rate that you need, and then you can adjust the air. And you may have a couple little tweaks to do, but it'll be something that you'll get pretty quick at. And you may even realize that, if I just leave my air damper here, I just turn the fuel up to where, so you may end up just having to adjust the fuel in future batches.
And I assume if you're making a big batch on a small burner, you don't necessarily want to run it wide open and have flames flying up the side of the kettle. And
that's right. Not only, as we talked about, the flames can damage the ancillary equipment, the valve and thermometers and level gauges and whatever you've got on the outside of your kettle. But that fuel really is now just being wasted. You're really not sending it into the kettle if the flames are rolling significantly past the edge of the kettle. You'll get a little bit that comes past, but you just don't want lots of flames coming past. It's really just wasting fuel.
And you mentioned there's safety concerns, obviously, with gas burners. You want to be on probably a good surface, right?
Yeah, absolutely. You want to be on a firm surface, and grass is not a firm surface. You want to be on, concrete, asphalt, compacted gravel, that kind of thing that is not only firm, so that it doesn't tip or settle, but that's also not flammable. And porches made out of wood are flammable and are somewhere where I really wouldn't recommend.
Probably not your back deck, huh?
Yeah, not the best bet. And of course you're working around, very high heats. Be careful touching valves and, thermometers, on the kettle, even the handle of the kettle, they're going to get pretty hot. And if it's an area where you need to touch, like a valve or the handles, and it's getting that hot, you probably ought to consider improving your shielding on the burner.
And then the other concern is ventilation. I know people actually try and use gas burners inside, which is probably not a great idea. No,
not really a great idea. They're best outdoors, and one of the main things is they're not super efficient as far as not creating carbon monoxide. So these burners do put out more carbon dioxide than what people probably realize, and that that's a poisonous gas. So it's best to have to use gas burners of this magnitude, propane burners in particular, outdoors, not only for the fire safety, and keeping it away from structures inside of your garage. I've been there living in, I grew up in Iowa, a little cold in the winter, and there's that temptation to just do it in your garage, but you're taking on some risk of not only asphyxiation, but of fire hazards. So
maybe set it just on the edge of the garage or just past the edge of the garage, huh?
Yeah. And of course, never use these higher powered burners for frying turkeys or heating oil. That you're really asking for trouble there, because it can very quickly overheat that oil and cause a pretty severe fire.
Yeah, you get what is it called? What's the effect when you drop the turkey and once the oil is supercritical?
Well, I just know that you've got a whole bunch of water that's going in there that flashes to steam, and it will just boil and send that oil over the top. Just
Yeah, you
very,
can
very
go on
violent.
YouTube and see that if you want to. It's pretty interesting. They had a number of these videos before Christmas. You basically, if you take a turkey and drop it in boiling oil, the whole thing will explode over the top, and it makes some explosive flames as well.
Yeah,
Pretty
it sure
nasty
does.
stuff.
So ventilation, it's been done, particularly with natural gas. But the big thing you want to make sure indoors is, obviously you want this located away from flammable things. Walls and floors should be non-flammable materials. But the biggest thing is ventilation. And not only do you want to get rid of the fumes from the propane or natural gas burner, you want to get rid of the heat so that your room doesn't get extremely hot. And then also the aromas from the actual boiling and the steam from the boiling. You want to evacuate that. So just some, quick rules of thumb. There's some articles. I did an article for Brew Your Own magazine on ventilating your home brewery. And just a couple quick rules of thumb. You need about 1 CFM per 100 BTU per hour of burner. That in general will move enough air to evacuate the room of harmful fumes and all that. The other is you want a hood to capture this, because you need to actually get that the fan to actually draw up those fumes and aromas and get them out of the room. And what you'll want is 50 CFM per square foot of hood. That's called that gives you a capture velocity. In other words, gives you enough suction that it will actually draw those fumes out of there. And you want to use the larger of the two. And those are some good rules of thumb.
Right, but for a gas burner, I think when we're talking about potentially thousands of BTUs here, or tens of thousands of BTUs, we're talking about a huge amount of air that needs to be moved, really.
Right, 500 to 700 CFM, cubic feet per minute. So they get fairly large.
That's a big fan. Yeah.
It is, yeah.
So probably best.
The other thing to factor in too with propane is heavier than air. So if you do have a propane leak inside, that propane is going to sit on predominantly on the floor, and if your furnace kicks in or it's some spark, it can be a very hazardous explosion or fire. So if you are using propane tanks, definitely store them outside. Don't store them in the basement. That's just asking for trouble.
Yeah. More good reasons to be outside. But let's talk about moving inside. We'll go to electric next. I wanted to cover electric as well. What are some of the advantages and disadvantages of going electric?
Electric really lends itself well to indoor use. Really about the only drawback of electric is, portability. If you want to, brew while you're camping, or if you want to, go to a friend's place and brew, that's really about the only limitation. It's very inexpensive, even in high electric rate areas. By the time you add it up, it's not very much. It's certainly less than propane is. So don't let the cost of that worry you. But there's really, I would classify as 3 basic types of electric heating. The most common is immersion heaters. What a lot of people use, repurposed water heater elements. There's a couple that are specifically designed for home brewing. That are, coil in shape. We have our boil coil, and there's some others, S-shaped and different things out there. The other is surface heating, and that's where there's a heating element that's bonded to the bottom of the kettle. You'll see those in things like the Robo Brew and the Grainfather. Are 2 that use that. That's, more of the coffee urn type heating elements. They have some drawbacks and benefits. And then one you'll see sometimes is induction heating. And induction heating requires a magnetic kettle. And what you're doing is this: you're actually taking the power in from the wall, converting that 60 cycle energy into 20 to 40,000 hertz, very, very, very high frequency. And what that is, so there's a coil that they have, a coil of wire that they have right on the under the surface of the induction, and what it does is it induces eddy currents, little small localized currents inside that magnetic material, and that actually heats that, locally heats that up. As soon as you turn that magnetic field off, then those currents stop, and and the surface of the induction plate is very cool, other than the temperature from the liquid sitting on it, or the kettle sitting on it. So they've got some great advantages. You've got some cooling fans in there. They're a little noisy. But one of the big limits in electric in general is how much power you have available where you want to brew. Typical residences are going to have a 15 amp receptacles. You may be able to put a 20 amp receptacle in at 120 volts, but that's going to limit you to at most 5-gallon batch, and even at that, it's going to be kind of a weak sauce simmer. You won't really get.
So a typical household circuit is what you're talking about,
right.
Is pretty much limited to about a 5-gallon batch, right?
Yeah, and even then the heating rate's
or 19-liter batch, I should say.
Yeah. Mm-hmm. So, and we have in the North America anyway, you'll pretty much have, I think even South America, you'll pretty much be limited to 120 volts for typical residential voltages. Most homes, at least everyone I've been to, has 240 volts available, but it's usually just wired specifically to things like water heaters, electric stoves, furnaces, that kind of thing. So you just won't have a 240 volt connection in your room or in your basement, or even in your garage necessarily.
Right. So the bottom line is, if you want to do more than a 5-gallon batch, you're probably looking at getting some kind of a dedicated circuit installed, right?
That's right. So that is one of the other drawbacks, is bring that in. But it's generally, some of that work you can do yourself if you're pretty handy. If you're not comfortable doing it, I definitely recommend hiring an electrician to do that. But it definitely makes the 5-gallon batch. I mean, it heats very quickly, and you can, depending on how much current you've got capable or available, you can do 20-gallon to, we've got commercial systems that are 7-barrel running on electric heating.
Probably 3-phase though at that point, right?
3-phase is easiest for commercial.
Yeah, I was going to say.
But sometimes that's not available.
Yeah. So just to summarize then, so if you're looking at doing under a 5-gallon batch, you could potentially do it on an electric stovetop, right?
Oh yeah.
A extract batch or something like that. If you're looking at doing a 5-gallon or 19-liter batch, just to be here, and we do work in watts, right? So then you could probably get away with doing that on a household circuit, right? Potentially.
Right. So I would say if you have 20 amp breakers in your panel, that's going to mean that the wire is going to be rated for 20 amps. So you could actually have an electrician change out your 15 amp receptacle to a 20 amp receptacle, and you could get up to about I think about 1800 watts, something like that. I have to do the math here real quick. If you're at 120 volts,
right. I should mention we're talking U.S. voltage here, so most of it's 120 volts. I know Europe, a lot of it's 240, right? But they don't. At the same time, they probably don't run the same currents either, right?
Right.
So they're running at roughly half the current. So it's still going to be very similar. You're looking at, about a 19-liter 5-gallon batch you might be able to do on a typical household circuit.
Right. So, moving up to the 240 volt, you definitely are going to have enough capability to do 5 and 10 gallon batches, even 20, even up to 20-gallon batches.
Right. So now we're talking about going from, say, 1,500 watts on a typical household breaker, and now we're looking at going to maybe 5 or 6, even 6,000 watts if you have a high, 30 amp, 240 volt circuit, right?
Right. For example, on a 10-gallon, 38-liter batch, you would typically see between a 4,500 and a 5,500 watt heating element, and that would be on we'd recommend about a 30 amp breaker for that. If you're going to do a 20-gallon batch, you're talking between 5,500 and 6,000 watts.
So pretty big, but you get a nice boil for that 5,000 or 6,000 watts, right?
You absolutely do, and you get pretty decent heating rates too. In fact, we'd like to shoot for about 2 degrees a minute heating rate, and a pretty simple formula for that.
That's roughly 1 degree C.
Yeah, roughly 1 degree C. That's right. I should have thrown in the real units.
Metrics, yeah.
Those are screwy ones. But we've got one of the simple formulas is 0.0068 times watts divided by gallons will give you your heating rate in degrees Fahrenheit. Let me see if I can real quick pop up the one for.
That's okay. But I mean, it gives you an idea. So I mean, it still works out to the same numbers. We're talking about 1,500 watts roughly for a 5-gallon or 19-liter batch, and you're getting, certainly into the 4,000 or 5,000 watts if you want to do a 10-gallon, 38-liter batch, which definitely drives you to 240, right?
Yeah, it does. Yeah.
So.
And most countries that are would have like 230 volt, and at 50 hertz, the frequency doesn't matter. It's the voltage and the ampacity. So, if you're outside of North America, you're in pretty good shape with just having that available throughout your home, which is kind of nice.
Yeah. So, I mean, the bottom line is you probably need a dedicated circuit to do a large batch. You can probably do most 5-gallon batches off a small household circuit. What about the one issue I want to talk about is safety and the importance of the ground fault interrupters, though, because a lot of people don't have that on their typical household circuit. It's in kitchens. It's at least in the States anyway. I guess it probably is everywhere. It's code that you have a ground fault circuit interrupter. So what a ground fault circuit interrupter does is it's looking for the difference in any kind of difference in current between your ground and your neutral. And if it sees any difference in current, it knows something's going haywire and it opens up the circuit. So it'll do that even though you're not at maximum amps. It's not like you have a short circuit. You've just got something going on where there's current going somewhere it's not supposed to be going. And that just quickly opens that circuit. And that's very important when you're working around water and fluids, right?
Absolutely. That's why, pools, hot tubs, sinks, anywhere where you've got water around, because that's such a good conductor for humans. You definitely want that kind of protection.
So again, for brewing, you'd also like to have a ground fault circuit interrupter, right?
Absolutely. Because you do have, it's kind of, there's a difference between an electric water heater where everything's enclosed and, you can't get your hand into the water because it's just an enclosed pressurized tank. With homebrewers, you've got an open tank that you could, reach in and touch and, and that could be energized. The water could be energized. It's a good conductor, but it's not enough where it would necessarily cause a short circuit and cause the breaker to blow open. So that's one of the reasons we really want, and we highly recommend having a ground fault circuit interrupter. They do make those for 240 volts, and you may need to have a electrician install that in your panel.
So let's go over the options. So if you're working with a household circuit, you do have the option of putting in a ground fault outlet, right, which are fairly cheap from Home Depot. Of course, if you don't know electricity, you want to have an electrician install it, but basically, it's just a special outlet that handles that, right?
Right. They're like 15 or $20.
Right. And then, but for the 240 volt, we're talking about something more. We're usually talking about putting a breaker in the panel, although I've also seen some boxes that go on the outlet side. They make them for like hot tubs and stuff. But generally, you're talking about actually installing a new circuit breaker, a GFCI circuit breaker that actually goes in your electrical box in the house, right?
That's right. That's right. And that's one where, unless you've done this before and you know exactly what you're doing, that it's worth, for the risk involved, it's worth having an electrician come in and install that.
I don't recommend you open up your home panel and start putting breakers in without an electrician. That's probably not a good idea.
Absolutely.
So I would recommend that. I'd recommend for either of these that you get an electrician, partially because of the insurance as well. If you start monkeying around with a lot of this stuff and you make a mistake, it may not be covered under your home insurance policy. So,
one other thing that we didn't talk about the heating elements is watt density. You'll hear some of that. You'll see, ultra low watt density, low watt density, all this. And I have searched and searched and searched for any definition of this, and I think it's really they're just more marketing terms used for residential water heaters, and just meaning it's likely to last longer is really, I think, what I've determined on that. But it doesn't really speak to a specific watt density. So over the years, having done a lot of these electrical heated kettles and whatnot, and seen a lot of different ones in operation, if you're below 60 watts per square inch, it's going to work. Ideally, you'll be below 40 watts per square inch. So what I'm really talking about with the watt density is how many watts per square inch is on that. How intense is the heat on one little spot? So you could have a very small heating element that puts out 5,000 watts. But you have to worry about that getting so hot localized because it's touching the wort that it could scorch it, versus that same wattage spread over a much larger surface area heating element. It's going to be a lot more gentle.
Which is why your typical element's a long coil, right? Immersion coil that goes in the pot, right?
Right. So they're fairly easy. And the other problem is most manufacturers don't list what their watt densities are until you get up into an industrial type heater, where people are designing for specific applications. But if you go to the store, it's really hard to tell. However, it's fairly easy to calculate. You basically measure the diameter of the wire or of the tube, and the length of the tube, and so the surface area is pi 3.14 times the diameter, and then you multiply that by the length of the tube. You'll want to take off 2 to 3 inches of the length, because they don't run the heating element all the way to the end of the wire, otherwise it'd overheat the wire. And one other thing while we're talking about the construction is you do want to make sure that the heating element is 100% stainless steel. Sometimes they'll use a stainless steel tube, but they'll use a zinc plated fitting on it, and that zinc plating goes away pretty quickly, and then it'll start rusting, and you'll get a tinny taste to your beer. So
I'd recommend buying a heating element that's designed for home brewing, if at all possible, right?
Absolutely, for a couple of reasons. One is, it's going to be made out of the proper material. You can get all sorts of exotic metals and things. Plain old stainless steel, was going to last multiple lifetimes. Yeah. Unless you dry fire it. But the other thing is just the safety aspect of it. These water heating elements are made to be installed inside of a water heater through a large fitting. I've seen a lot where people are using just sandwiches of O-rings and nuts, and it's really questionable. Are you getting a really proper, good ground on that to make sure that you don't, you're not setting yourself up for, electrocution situation. So having one that's specifically made for home brewing is a good idea. We've gone through and done you all listed ours for use in an open container because safety is so important. So bear that in mind. As you're doing that, going cheap isn't a good idea in a situation where you're talking about safety. So
yeah. And of course, along those lines, you have to have some kind of a controller for your electric brewery, right? You got to have some way of controlling that heating element. What are some of the things you look at for a good controller?
Well, the first thing not to look at is your receptacle. Plugging it into a receptacle is not a switch. There's no on off on a heating element. It's if you put the voltage on, it's on. So what happens when you just plug it into a receptacle to turn it on? It's going to arc. Because it's just got this huge instantaneous load, so it'll arc inside.
Nice big power surge, huh?
Yeah, so it'll work for a few times, and then the more you arc, the lower there's contact resistance builds up, and then all of a sudden it starts getting hotter and hotter, and then it's going to completely fry, which is not a safe situation. And and then you've destroyed your plug and you've destroyed your receptacle, and hopefully haven't started your house on fire. But that's not acceptable. So if you do just want on-off control, you can find a switch. And put that in a box, but you'll definitely want to make sure that it's rated for the current and the voltage that you're using. But what you'll see a lot are there's two things you've really got to decide. If you're just doing it for a boil kettle, say you're doing brewing a bag, or something where you're not necessarily needing the temperature control, you can just get a power control, because that's the other thing is with a heating element, it's either on or it's off if you just plug it into power. It's not like a burner where you can turn the valve down to reduce the power. So you do need something to control the power, and there's a number of very basic dimmer switch kind of based units that will reduce the voltage supply and therefore reduce the power to your heating element. If you reduce the voltage, you can reduce the power that goes into your heating element. That's the most simple type. They're not real linear. Then there's some that use a nice linear digital control, so you can really dial it in. And then the next step up is temperature control. So the power control is great for if you're just going to do brew in a bag and you're going to be there, and you can heat it up, turn it off, maybe add a little heat if you want to try to heat it back up, but do be careful with particularly with brew in a bag and immersion heaters, because they can scorch that bag, and you definitely don't want to heat with inside of a mash. That's just, I guarantee you're going to scorch because you need that convective flow. The liquid needs to flow to cool off that heating element. It's actually heating up the liquid or cooling off the heating element. So definitely if you're going to heat for a brew in a bag, you want to lift the bag, heat for a bit, and then put the bag back in, and then do some stirring to kind of, if you need to maintain some temperatures. Mm-hmm. So so for temperature control,
let's talk about automated systems. So beyond the basic just turning the element on and off, what kind of temperature control automated systems are available?
Well, the simplest type would be like a Ranco controller or Inkbird controller. However,
PID controller or something like that.
That would be the next step.
Okay.
It's tempting to want to use a Ranco or an Inkbird controller, but the problem is they use a mechanical relay, and those relays are typically only good for about 10 amps. So you're going to fry the relay out of there pretty darn quickly. The other thing is turning those, every time you turn that on, at that kind of full power rating, the contacts just don't last a really long time. So that's something to factor in. You generally can't use those in a home brewing application. You would have to move to an industrial type relay. So what's typically used is a PID, and the PID stands for it's an acronym for proportional, integral, and differential. And that's the control schemes that have developed over the years. There's proportional control, which is the closer I am to the set point, I'm going to pull the heat back a little bit so I don't overshoot it. And that's what it's all about. So if you just turn your heating element on until you get up to your set point and turn it off, there's going to be a little bit of overshoot. And then when it comes back down, you'll want to have to turn it on. So on off works okay. But proportional is the next step. Integral and differential. I won't go into all the details behind those, but they generally make things worse in a heating application. That's a real slow heating application. Those are for fast moving systems. So proportional control is all you really need in a PID. You can read the manuals and it can show you how to set those. Most of them are auto tuning as well. So what that really does is it uses a temperature sensor inside of your kettle, or in the if you're doing a rim system, you'll put that in the circulation loop as opposed to in your mash. And the reason I say that is if you try to put it in your mash, I will guarantee you will have overshooting and undershooting temperature issues trying to control it that way. If you control the temperature of the returning wort going into the top of the mash, it'll work very, very well and be very stable and won't overshoot. Mm-hmm. So so you'll have a temperature sensor somewhere in the system, and the controller's looking at the temperature and deciding, do I need the heating element on or off? And so what it does is it sends a signal, most commonly to a solid state relay, otherwise known as an SSR. So it's got a giant transistor, if you will. It's typically they're a triac, to be specific. There's a number of different types, but basically there's no moving parts in it. It uses solid state devices, so you don't have to worry about them wearing out. They do generate heat, so you do need to have a little bit of a heat sink on them to keep them cool and extend the life of them.
And then I assume that drives the heating element itself, right?
That's right. So so you'll provide a small signal to a couple of terminals on that solid state relay, and then it will close the circuit and energize your heating element. And those, they have those up to, I've seen them as high as I think it's like 150 amps. So they're not ridiculously expensive, and you can find them on Amazon and McMaster-Carr, which is the greatest web page on the planet as far as I'm concerned. You could build the space shuttle out of that web page.
We should try that one day.
Yeah. So those are things that you can. They're fairly easy to build if you're electrically inclined. You can get kits from companies like Electric Brewing Supply and just a number of other places.
Or you can just buy a controller off the shelf, right?
Right. We've been making a product like that for a lot of years. I don't know, 8 years probably now, something like that. And you'll see, you can just do a search on the net and find a lot of manufacturers that do that. One thing you'll want to know is what amp capability and volt capability they have, and they're not inexpensive, but it's one of these buy once, cry once kind of things. So readily available. You can build them yourself. You can buy completed units, and they're great. They will typically control within a degree of where you want to be, a degree Fahrenheit, half degree C.
Yeah, I think your unit's called Tower Power, right? Something like that.
Yeah, we have our Tower.
You have an
power
electric one, right?
And then we also have a power controller, and we have a new power controller that's should be out by the time this is published. So
sure. What's that going to be called?
It's just going to be called the power controller. We couldn't think of a really cool name for it, but what we were able to do is really get the cost down on it, because we do know that a lot of people are wanting to get into brewing, and this is just I think it's like the entry level model is about $125.
Wow, that's great. Yeah.
Yeah. Mm-hmm.
That's for an electric controller for probably like a 5-gallon batch, right?
Actually, you can do up to 30 amps with it, so you could go all the way up to a 20-gallon batch size, up to like 6,000 watt heating element.
Yeah, that's quite a bit. Yeah. So. Nice. And I skipped over it, but you can also have controllers for your gas system as well, and I think they just turn the burner on and off, right?
Right. Yeah, that's a very good point. Our Tower Power line has got both the PID based temperature controllers for gas and electric. And the gas, basically, you'll have some kind of ignition system that will, some are piloted, like with a little pilot light, and you turn the valve on and it lights, and others use the electronic ignition, that has flame sensing and all of those things for safety.
So they basically cycle the burner on and off as
That's
needed, right?
Yeah. Right. Yeah. So it's just turning that burner on and off automatically for you, and again, and it uses that temperature loop and the control scheme from the PID.
Well, we're actually pretty much out of time, but I wanted to go ahead and give you a minute or two to give your closing thoughts on heating elements, both gas and electric.
The gas is easiest for outdoors. Propane and natural gas easiest for outdoors because you don't have to worry so much about the ventilation. Indoors, electric is ideal. A little bit of an investment getting the equipment and getting the power over to where you want it. But it's also a lot easier to ventilate. You really only have to worry about getting rid of the aromas from brewing. But do make sure with these things that you follow the safety requirements for operating the burners in a safe way. And with electric, highly recommend having a professional electrician get you set up and get you going so that you're operating safely. And always buy a real nice quality heating element. It's a one-time investment and will last you many, many years.
And don't forget that ground fault indicator, right? Or GFCI, I should say.
Interrupter. Yep, definitely. Definitely want that.
Yep. Well, John, really appreciate you coming on the show. Thanks for coming.
Absolutely. I always enjoy helping out wherever I can.
Always a pleasure to have my guest and good friend, John Blichmann, on. He's the CEO of Blichmann Engineering, makers of high-quality home and professional brewing equipment. Thank you again, John.
My pleasure.
Well, a big thank you to John Blichmann for joining me this week. Thanks also to our sponsors, Craft Beer and Brewing Magazine. They have a new Craft Beer and Brewing Magazine podcast, which I encourage you to check out. It features some of the top craft brewery owners and brewmasters discussing brewing techniques and flavors in beer. It's the podcast for those who make and drink great beer. You can find it on iTunes or at beerandbrewing.com/podcasts. And also Blichmann Engineering, creators of the Riptide Pump. Designed for home brewers, this brewing pump features a whispered, quiet, sealed housing, a removable tri-clamp stainless steel head that makes it easy to clean, and a built-in relief valve for easy priming. Get the Riptide Pump today, another great innovation from BlichmannEngineering.com. And finally, BeerSmith 3 is available now for download for both desktop and mobile platforms in time for Christmas. BeerSmith 3 adds mead, wine, and cider support, new Whirlpool hop options, support for high-altitude brewing, and a whole lot more. Check out BeerSmith 3 software and get your free 21-day trial today from BeerSmith.com. Thank you for listening. I hope you have a great brewing week.